Now recording. So, last time we sort of briefly introduced comparison operators, and we talked about operators quite a bit. So, I think we need to get some practice in. We're going to do a few flowcharts. I'm going to put a flowchart on the board, and as an exercise, you folks will translate that flowchart into a program in C#. Sound good? Okay, let's do it. There we go. Oh, and for this one, everything can be integers. There's the flow chart for all you folks viewing from home. I recommend getting in the habit of using the curly braces. Curly brace should start after the if. You should also get into the habit of using curly braces. Oh, I see. That semicolon is not correct. Yeah, asterisk is multiplication. Sorry. This is a little far back. Yeah, that's a 4. Yeah. Because it's the statement isn't over yet. substatements. And when you're using these opening and closing lines, you don't. In fact, don't. There are some languages that require you to put one there, but not this one. Particularly bash scripting would require you to put one in there. That's okay. Although, next semester you guys will read the bash on the networking. There's a course on networking side of things. Yeah. Nice.
What's it? So I'm planning on doing the project. If I know what to do, I just let them put it through random numbers.
Oh.
Within sets.
Ah.
So I'm like,
Let's see if I can remember this. It's
those are just not simple. So it's a bit.
you kind of have to do a little bit of object-oriented stuff. So, by default, so that will return a random number between 0 and 9 probably. I recommend reading the documentation. That's hard to say. First, check the documentation to make sure it returns an int, not a double. Second, check to see if it's inclusive or exclusive of that final number. It will depend on what language you're using and what library you're using, but that's how you make a random number, my friend. So how many people still working on it? So, errors, always start at the top and go down. So you see this little green guy? That's actually incorrect syntax. What you want is something that looks like that. These curly braces are actually redundant. And after the else case, you should also this line, like, just print is not going to work. We have to say console.write. But of course, that also has to go inside. Yeah. Got it? Yep. Good. Good, good. Okay. Important. You have listed y is less than 17. Up here I have y is less than or equal to 17. I know it seems like I'm being pedantic, but like a thing that you and hopefully everyone else in this class will come to appreciate quickly about programming code is that one character is the difference between success and failure, right? just the wrong equal sign in the wrong place is a bug, right? So a skill that everyone in the room should develop quickly is, when I say, like, write this down, I mean exactly to the character. You must be precise. So I'm sorry, I guess I was picking on you a little bit. It's really,
No, it's okay.
like, you got the overall structure, like, correctly. It's just, you're
Should I
just,
just put the equal sign or
yeah, just like this, actually.
oh,
So, this is the programming code equivalent of less than or equal to, as opposed to just less than, right? Which means that if y is equal to 17, in this one, this print statement will still happen, because less than or equal includes equal. But in yours, you would go down the false branch for that.
but then you gave me yes as well, that's a problem.
Well, yeah, because y is 12, right? This is a somewhat silly example, right? Because we are just using static numbers, right? So, anybody still working on it? Would you like to see the solution? If you're good, put your thumb up. All right? You guys still working on it? Okay. I'll give you a moment then. Well, just delete that semicolon, put this in round braces, and that will help tremendously. You're also missing a semicolon. Yes, because this, like, okay. Control J, Control D. There's, what's the Arlo format hotkey? I forget. Let me look it up again. Yeah, it's Control K, Control D. Okay, so it's probably, it probably doesn't like it because you've got a syntax error. It should say something like semicolon expected. Semicolon expected. If you double click that, it'll show you what line it's on. Double click it. Right there. Semicolon expected. That is a colon. Now, there you go. Well, yeah, like the if statement doesn't get a semicolon. The curly braces apply to the if statement. The sub-statements inside of the if statement do still need it. So, Control K, Control T. So Control K, Control D hot button sequence auto formats your code in Visual Studio. However, that's somewhat dependent on you getting all of the syntax right in the right places. If you're having any errors, I highly recommend taking a look at your error list. It will tell you when it expects a semicolon and doesn't see one. So, shall we see the solution then? Everybody prepared? All right. So, int x is equal to 3. There I go. Int y is equal to x times 4. Oh my goodness, go away. Go away. There we go. As you may have noticed while you were doing that exercise, the autocomplete is not all that helpful. If y is less than or equal to 17, console.write line yes. Else console.write line no. If you run it, I said if you run it, there we go. Yes. Good. So this example is a little bit silly. Because of the way that the program has been written, there's no possible way to exercise the false branch. So let's introduce a slight modification so that rather than simply hard coding the value of x here, we are receiving input from the user through the console. By the way, when you set a variable value at the top and you just keep it for the rest of the program, that is what's known in the business as hard coding. So we're going to remove this statement here. And we are going to replace it with take user input for x. Let me show you how to do this. So the console is where we print information out. It's also where we receive information in for a console application. So console.writeLine, please enter an integer value for x. If you don't prompt the user for the information you're expecting, the user will not know that it's waiting for input from you, right? So you must prompt the user if you're expecting input. Then console.readLine. This is the command which reads a line of input from the console. That is to say, it will read a number of keyboard presses that are made in the console until the user presses the enter or return key. By the way, do you know where the term return comes from on keyboards? Because Macs still use return, right? Rather than enter. That, again, again, is an old convention from typewriters. A return operation is actually carriage return. So the carriage is the thing on top of the typewriter that holds the paper. So when you press return, you're asking to return the carriage to its original position. So, you may notice that we're getting a syntax error. Or more exactly, we are getting a type checking error. Console.readLine returns a string. This makes sense. When we read from the console, we are reading in a series of characters. We do not yet know whether or not they are numeric. So, in this context, we wish to try to convert them to being numeric, so we must add the following. Well, actually, you know what, let's separate it out. String input is equal to console.readline. Next, x is equal to convert dot toSint 32 for 32 bits input. Don't worry about that warning. So, running this program, we now get, please enter an integer value for x. If I enter 5, you can see that 5 times 4 is 20. 20 is less than or equal to 17. True or false? 20 is less than or equal to 17? False, yes. So we end up exercising the no branch rather than the true branch. Question?
Mr. Nick, I have a question. So why didn't we just give x a 5 from the beginning? What would happen?
Oh, you mean hard code a 5 up here?
Yeah.
We would have gotten no every time we ran the program. See, the difference is now we can choose what x is going to be for each run of the program, right? Another way to say this is that we have made the program parametric on x. We have made x into a parameter. That's going to become important once we start talking about functions, or functions/methods. Any questions about this? Shall we do a slightly more fun example? If you want, you can put in basically there are two schools. So, here's the program. First, you print what kind of bear is best. Then, read input from the console to a string variable. If the user responds with black, congratulate them. If they do not respond with black, admonish them. I suppose it was actually question. How many people have finished that? How many people are still working on it? Okay. I'll hurry up. Oh, I think it's because of unresolved syntax errors, so it's defaulting to the last build that worked. So you must. And you need. Oh wait, actually no. You need to put brackets around that. Yeah, there you go. Yeah, that's, there's only a passing resemblance to the solution. Was it the autocomplete that was doing that? The structure overall is very similar to the last one. Oh, here, let me show you a quick. Here's multi-line comment, I'm trying to do that. Slash star. Star slash. Comments out of block. Do every line. Alright. Alright. Solution. Console.writeLine. Question. What kind of bear is best? String response is equal to console.readLine. Just like that. Now, here's the tricky part, right? I didn't actually tell you what the variable's name should be here. Most of the time, when you are actually programming, the name of a variable is your own decision, right? You get to decide. You should try to pick something that makes sense. You should try to name the variable something that will help you remember what it was for 3 months later when you've forgotten all about this program that you've written, right? So in this case, I have used RESP, not RESPECT, but RESP as a shortened form of response. I could just leave it as response as well. This unambiguously tells me that this is supposed to be a response of some kind, which of course helps me to understand the program later. Much more so than if I had just called this X, Y, or Z. Right? While I certainly do have a tendency to use X, Y, and Z for like simple numeric things when we're just doing a simple number example, in a real program, you should rarely, if ever, use, basically the only situation where you should be using single letter variable names is when you're writing loops and you need an indexing variable or something like that. But just a rule, not really a hard rule. So, if response is equal to black, we say console.writeLine correct. Good job. Else console.writeLine wrong. There we go. Run this. What kind of bear is best? Grizzly. Wrong. What kind of bear is best? Black. Correct. Good job. Good. Question.
I used input instead of response.
You used what?
I used input, I got rid of the other input that we used.
Oh yeah, the variable name doesn't matter.
Is it a variable name?
It's just a variable name, yeah. You could have called it supercalifragilisticexpialidocious and it still would work. Although, I wouldn't recommend that as a variable name because even in universe, that's just a nonsense word. Yeah. Yes?
If we're gonna talk about naming variables, I just don't know if everybody else knows about the lowercase, uppercase rule for multiple words on variables.
Oh, yes.
Grammar-wise.
There are actually a couple of different conventions on that, yes. So, most programming languages will permit you to have underscores as parts of variable names. So, let's say you wanted a variable name that had more than one word in it, like, let's say like player 1 response, for example, right? Now you could write this as P1 response, but it's a little bit ugly, right? Let's actually write that out. If you take away the spaces, you get player 1 response, which is like player owner response, So there are two, there's more than this, but there are two main ways that people deal with that. One is to exchange the spaces for underscore characters, which works perfectly well. The other, which is my preferred way of doing it because I come from a sort of Haskell functional programming background, is to use something called camel case. Player 1 response. So basically you just capitalize the first letter of every word that is not the first word. So you may be asking yourself, why not this one? And the answer is, in object-oriented languages, capitalized identifiers are conventionally reserved for object names, not variable names. So we give them to something else. Or custom user types is another way of sort of. So if you were to put a big P, an uppercase P here, somebody who is familiar with conventions would say, oh, this is a type. This is a class name rather than a variable name, which is not the case. So lowercase, please, on variable names. Make sense? Thank you for that. So here's a question. In this program, we run this once and we're done, right? What if we wanted the user to try again if they get it wrong, right? Let's say we want the user to receive a prompt saying that they got it wrong and then asking them to try again, and they keep doing that until they get it right. Yes?
You'd use a loop.
You would have to use a loop. That's right. So let's take a little bit of a look, see what that might look like in our flowchart, and then I will show you how to do it in code. So, wrong, try again. Then we prompt the user, or sorry, read the input. That is the prompt above there. We read the input a second time, and then we want to return the control flow to the top before we make the evaluation. And this now becomes the only way out of our program. Can you guys over on this side see that? Is it, you can see that? So, this kind of structure where we take the flow of a program and return it to a previous point in a program is called looping. It's also called iterating. In order to do this, we require another completely different control flow structure. We are, in fact, no longer using an if statement. We are going to transform the if statement into something completely different. So, we will be making a while loop. Now, the nature of these branches has changed. So what we actually want here is to execute this loop so long as the response is not equal to the thing we're looking for. So if we exchange a equality for an inequality operator here, that makes this the yes branch, and this the no branch, and everything works nicely. Because this is how a loop works. Loops have conditions, just like if statements. A while loop will execute the loop itself, this being the loop itself, so long as this condition is true. If this condition becomes false, then it breaks from the loop. It breaks out of the loop and continues with the rest of the program. Allow me to demonstrate. So, while response is not equal to black, we want to tell the user they're wrong and that they need to try again. You notice that the loop, the else here has now become a syntax error. While loops do not have else cases. Anything you want to execute after the loop has finished should be placed below the closing curly brace of the loop. Does this make sense? inserting response equals console.readLine inside of the loop body satisfies this second thing that we were trying to do. Hopefully, this reads intuitively. Like if you just read it and sort of parse it with your English language circuits in your brain, this should make some degree of sense. While response is not equal to black, perform console.writeLine wrong, try again, perform response is equal to console.readLine. The lower curly brace, this guy here, should be interpreted as return to the top of the loop. So go back up here. Shall we see what that looks like in execution? Question: what kind of bear is best? Grizzly. Wrong, try again. Polar. Wrong, try again. Brown. Wrong, try again. Panda. Wrong, try again. Black. Correct. Good job. Any questions? This is your brain. This is your brain on C#. Wow. Do people not get that reference anymore? Possibly. It's a famous anti-drug ad from the 80s. This is your brain on drugs. And it's got like an egg in a frying pan. Yeah. Zoomers.
I got it.
Yeah. All right. So, let us take our newfound knowledge and let's try it in application. Does anybody mind if I erase this? Let's try writing a loop that does something numeric and simple. here is a program for you. I is equal to 0, or assign 0 to I. Enter a loop, checking to see that I is less than 10. Print I is equal to I plus 1. Return to the top, and when it's finished, print done. I'll give you a few minutes. Oh, they gotta be in the same loop. Yeah. Yeah, when you see like the number of loops will be the number of diamonds that you see in a flowchart. Yeah. And we are going to swiftly move beyond our ability to put a program in its flowchart as well. They're going to get too complicated, so don't become overly dependent on the flowcharts. So I intended you to print the value of I. Yeah. So if it's not clear, I intended you to print the value of I here. So in the console, it should go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then cut off. And say done. That bit is its own line. Doesn't go inside of the console, but the console, that would be fine. just lines of code as things that you're writing to console. So in this example, we are not actually taking any inputs from the console.
Okay.
So you don't need a response variable at all, actually. Everything's operating on I, where I is an integer. Yeah, you're making the same mistake. Yeah. So I is an integer, you don't need to read anything from the console. Because indeed, this flowchart does not say anywhere, read something from the console.
Is this right? Okay, I did it.
So, do you see any structures in the flowchart that would be corresponding to your statement?
No, but like I have to separate them to, like they're gonna get a different result.
But recall that done should be printed when the loop is finished. Is this line inside or outside of the loop? So it won't execute when the loop is finished, it will execute every time. Right? Everything between these curly braces executes every time the loop runs. Right? So that guy should go down here. Do you hit Control C and then delete? You know, cut,
This one?
Control X.
Not
Yeah, that's the same operation actually, because that's a common operation, right? Yeah. Yep. Control X is cut. Control C is copy. Control V is paste. Yeah. Okay. Y'all ready to see the solution? Int I is equal to 0, while I is less than 10. Console dot write line I. Note that I is not placed in quotes here. If I had put I in quotes, then I would be literally printing the string containing the variable name, rather than interpreting this as the value of the variable. Finally, I is equal to I plus 1. This is actually the most important line in the loop. Then, console dot write line, done. In execution, if it does actually execute, I don't know why it like sometimes mysteriously fails like that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, done. Wait, I said 10, I shouldn't have. So, here is the difference between less than and less than equals. Notice that with less than equals, we iterate the loop one additional time in the case where I is equal to 10. Does this make sense? Any questions about this? So, allow me to talk briefly about this line and how important it is. as a demonstration, let's comment that line out, run the program, or run the program. So you notice how this program is just printing infinite zeros. What we have done here is we have created an infinite loop. Infinite loops are one of the primary causes of program crashes. If a program mysteriously stops working and just stops, right, and you have to kill it using the used to be Control Shift Escape. If you have to kill it with the Control Shift Escape menu, in Windows at least, there's a pretty good likelihood that you've run into one of these. This thing will actually just keep going until the computer eventually breaks of old age, or the power supply is interrupted, which is more likely. Infinite loop actually does mean infinite loop. So why does that happen? Let's perform a simple program trace. A trace is when you make a chart and run through your code by hand to see what the variables are doing. So, in this case, we only have the one variable I. So, on line 3, we create the variable I. What value are we instantiating? 0. Good. I'll do the normal one first. I'll do a trace for the normal one. And you know what? Just to save myself some time, I'm going to change this to 4. So, line 4, we hit while I is less than or equal to 4. Is I less than or equal to 4? Yes. So we proceed to line 6. Line 6, we print it. At the moment, we don't care about that. All we care about is modifications to the variable. Line 7, I is equal to I plus 1. What is I? 0. What is I plus 1? 1. So we assign I plus 1 to I. Next, we hit the end of the loop. We go back up to line 4. Is I less than or equal to 4? Is 1 less than or equal to 4? Yes. So we proceed to line, let's skip 6, go straight to 7. Line 7. What is I?
6.
I is 1.
Sorry, that's 7 on there. I thought you meant like 7.
Oh, with line numbers, yeah. No. I plus, so I is 1, I plus 1 is, we assign that to I, 2. We then proceed back to line 4. Is 2 less than 4? Less than or equal to 4? Yes. So we proceed to line 7. I is 2. I plus 1 is 3. 3 gets assigned to I. Proceed to line 4. Is 3 less than or equal to 4? Yes. Proceed to line 8. That would be the end of the curly brace. Proceed to line 7, because we're skipping 6. So line 7. I is equal to
3,
3. I plus 1 is equal to assign 4 to I. Proceed to line 4. Line 4 is I less than or equal to 4? Yes. Proceed to line 7. I is equal to I plus 1 is equal to 5. Assign 5 to I. Proceed to line 4. Is I less than or equal to 4? No. So, we proceed to line 9, skip line 10, print done, program terminates. Everything in a program breaks down into, fundamentally breaks down into simple mathematical operations. That's all that a program is it's an organization of simple, easy to calculate in your head, mathematical operations. At least when you're applying them to math. The power of computers is that we can abstract and modularize these simple mathematical operations so that we don't have to think about them to perform other operations. So, for example, when a computer calculates a square root, it doesn't have a giant table of square roots for every possible square root, right? Because you can calculate the square root of like doubles, right? Numbers with decimal points. It would be infeasible for the computer to have a table for the square root of every single decimal point. It has an algorithm for calculating it, right? But you don't need to know it. You can just think, okay, it's calculating a square root. Incidentally, the way that you get at those types of things is through the math library. Math dot, and then it's got all kinds of fun operations, including square root. Now, square root is, in most programming languages, abbreviated to SQRT, which makes it look like squirt and not square root, which is kind of humorous. But if you're looking for your trig functions, sine, cosine, arcsine, arctangent, all of that stuff is available through the math library. Good. Any questions? There haven't been many questions today. Perhaps this is because everybody gets this stuff, right? Like, the theory isn't that complicated, right? Hopefully, like, the idea of what's going on here isn't difficult. What you're getting tripped up on is where do I put semicolons, where do I put curly braces, that type of thing, right? And unfortunately, that's just practice, you know? You just have to practice it. So, I know this says Java, but don't worry about that for the time being. Yeah, actually, I'll see if I can find something equivalent to that in C#. So, yeah, this is a good one. w3resource.com/C# exercises. Lots of C# programming problems, which you can try over the weekend or whatever, whenever you have a moment. Do as many of these as you need to start to really be able to bang these things out without thinking about them. Right? Here, I'll put the URL larger. So, for example, write a C# program to print the sum of two numbers. Perfect exercise. Exactly. Write a C# program to print the results of the specified operations. Here are some operations, you know. It even gives you the expected outputs. Swapping is kind of a fun one as well. That tests to see if you understand how memory works. So, this one is one we could do right now, actually. Print a multiplication table taking a number as input. So, enter a number, 5. Expected output is 5 times 0, 1, 2, 3, gives the results. That's a good one. Let's try that one right now. And here, we will work without a flowchart. For this exercise and other exercise while you're practicing, I recommend turning off the code suggestions in VS Code. When it brings one up, there's a little gear icon that will bring you to the menu where you can turn them off. Not even just because well, for two reasons. One, the code suggestions may or may not be helpful. They're much more likely to be unhelpful than helpful. And B, they're just distracting, you know? Basically the problem with code suggestions is that in order to figure out whether the thing they're suggesting is good or relevant, you need to have had more practice with code than you currently have. You know, you're currently somewhat lacking the ability to discern whether code will work or not, right? So it might just be throwing a bunch of false information that, is not going to be useful and just distracting and slow you down ultimately. And because I'm kind of an old school kind of guy, I think reliance on the squidgy gray thing between your ears is usually the best course of action anyway. You need to think about that line, yeah. But otherwise, you're doing very well. So I'll give you a bit of a hint with this one. It is possible to mix strings and variables inside of an output, inside of a console statement. We don't usually do this, or we haven't done this yet, but you can do stuff like I is equal to this, and when you print it, or when you run that, you'll see that you get I is equal to 0, 1, 2, 3, and 4, right? So you can mix a regular string up with the outputs of variables just by using the plus as concatenation and building it up, if that makes sense. That is probably the easiest way to print out the multiplication formulas that it's doing here. The other way to do that would be to console.write instead of .write line, which will basically, it lets you print stuff without putting the new line in, so it doesn't bump you to the next line. So you can say something like, some symbol, and it just smudges the lines together until it hits the right line, then it bumps to the next line. That's the other way of doing it, but I think using the plus signs is easier and faster. Oh, you want the question back up? What's more useful, the question or the code? The code? Okay. I'll leave the code up then. have a name for the group. Or do you? Yeah. Oh. There Right. Let me see your code. Well, first, the thing it counts by should be read from the console. And then I'll give you a hint. You'll need two variables. You're actually computing the factorial. That's because you're not modifying J, but you're expecting to stop when J is modified. Pardon me. This is the formatting you're working on?
Yeah, essentially, so it actually sounds like it looks like a. Oops, sorry. That's it. Now I'm gonna do it, so I have to start forward.
Mhm.
My answer times whatever x is equal to. 4048.
Yep. But that's kind of like you've got the logic down. It's really just a matter of formatting it.
I haven't coded since like 2018, so it's really like, before that I did a lot of coding, like in high school and stuff like that, it was like, how they had to do like competitions and stuff.
Oh, yeah.
I did like a bunch of that stuff, like a lot of that stuff, but just like the high school. Really just kind of remembered everything I once knew.
Mhm. Yeah, well, like what language was it? Was it
So like I did a little bit of everything. I used C#, I think we started with C to be honest, and C# and C++. And then they kind of like branch out, so I did some like HTML5, which was like like and the creative project stuff, and
Cool.
I can't remember if I did any Python, it was mostly just a little bit of Java and
Mhm.
C#, C++. When I was in university, it was just, we just did C++ as like it is, but it was kind of more than.
It'll come back to you quickly. C# has like its own little things, but like there's really no major difference, at least at the level of the stuff we're talking about here. There's no major difference between C# and Java and C++. Really. They're all dialects of the same language.
I was looking through some of the pulled up code that I pulled up, and I was like, oh, it's looking like some good stuff and all of arrays, and I remember
Aw, poor arrays. Yeah. Arrays are awesome. I love arrays. I hope someday I will transfer my love of arrays to you.
hopefully, fingers crossed.
Okay, I think I have just enough time remaining in class to do the solution for this one. So I think we kind of have to cut it short regardless where you are in the problem. So So, we must prompt the user for a number. Console.writeLine. Enter an integer, please. Then we take the input. String response is equal to console.readLine. Then we must convert it to an integer as we expect an integer. Int n is equal to convert dot to int 32 response. By the way, this is a function. I misspelled it. But response is being provided as a parameter or input to the function. That's what the round braces do. ReadLine is also a function taking no parameters. That's why there's nothing there, because it doesn't require any input from the program, even though it requires input from the user. So, while I saw a lot of people were like, it's a lot of people were discovering that it's very easy to extend your loop condition and print the times tables all the way to like 3,000 if you really want to. But to demonstrate the principle, I shall say I is less than, while I is less than 10. I, of course, not being initialized yet, int I is equal to 0. This will be our iterator. At the bottom of the loop, I must be incremented. Another shorter way of doing this is I++. Now, all that remains is to print the equations. Console.writeLine. Let's write n times, even though that's not, like we use multiplication in code, a normie who reads this will see x as being multiplication, times I is equal to n times I. Enter an integer, please. 11. And there you have it. Or I suppose it wanted you to do it up to and including 10. Very simple to fix. How do I modify this code to change it so that we're doing up to and including 10?
We add an equal sign.
Very good. Good. Any questions? Wonderful. So, I think that's about as much damage as we can do for today. Sorry, you had a question?
Yeah, it says that we have to do a lab 0, where we have to create a Unity game and do something. Do we still have to do that?
That's just for practice.
Practice on?
Yeah. You can, if you submit it, I will take a look, but if you don't, I don't care. Honestly, I'm much more concerned that you do some of the exercises. Like, what I'm trying to do this semester over last semester, to try to improve the course and also improve educational outcomes, if you want to put it that way, is I'm trying to do a bit more of the Cody stuff and a little bit less of the Unity stuff, because like these are the skills that will follow you in every other language, right? You're never like, it's not going to be relevant to you in any other language to be able to draw a debug ray in Unity, right? But a loop is a loop is a loop is a loop, right? All languages have loops, except for the ones who don't. But you will probably never ever program in any of the languages that don't have loops. Incidentally, quick question for the crowd. If you're not using loops, do you know what you're using instead? Any people who have programmed before? Anybody? What's the alternative to a loop? Begins with the letter R. Nope. Good guess though. It's R E C U recursion. There we go. Very good. Yep, recursion, which you don't have to worry about at all in this course. It is how you would say an advanced concept. So thank you very much for your time and attention today, folks. I'll see you next week. Study, study, study. Like actually, please, please do actually try some of these problems. Try 1 or 2 per day. Like set yourself aside, 20 minutes, 30 minutes per day for practicing these coding problems. For memory, you want this stuff to be embedded in your long-term memory, which means a little bit each day is much better than spending an entire Sunday afternoon once a week, right? It's a superior mental strategy. So, good. All right.
Thank you.
Good work, everybody.